In this lesson, I'll show you how to solve exponential growth and decay with differential equations. The question reads, a crate falls from rest from an airplane. The air resistance is proportional to the crate's velocity, and the crate reaches a limiting speed of 66.4 meters per second. A. Write the equation for the crate's velocity, and B. Find the crate's velocity after 0.75 seconds. In this type of problem, an object falls through a fluid, in our case it's air, which exerts a resisting force that is proportional to the velocity of the object and in the opposite direction. We set up these problems using Newton's second law, which is force is equal to mass times the acceleration, and we'll see that the motion follows the law of exponential growth described in the previous video, where we learned how to derive the exponential growth to an upper limit formula. And I'll write that down. It is y is equal to a bracket 1 minus e to the power of negative nt. So let's get started with question A. We'll start off by writing Newton's second law, which is force is equal to mass times the acceleration, and this is equal to m, which represents our weight, divided by the gravity, where g, our gravity, is equal to 9.806 meters per second squared. So dividing the weight by the gravity will end up giving you the mass. And in place of the a, I'll put dv over dt. And this tells us the derivative of the velocity with respect to time, and that's another way of representing acceleration. Now, if we take the downward direction as positive, the resultant force F is equal to W minus kV, where K is a constant of proportionality. Let me show you what I mean. Force is equal to W minus kV. So V is our velocity, and subtracting the weight from the velocity gives you the force. This leads us to the equation W minus kV is equal to W over G dV over dt. We can find k by noting that the acceleration must be 0 when the limiting speed 66.4 meters per second is reached. Therefore, if I place 66.4 into v, our force will equal to 0, where we have 0 is equal to the weight minus our constant, 66.4. And from here we can solve for k. Bringing this w over, we end up with negative w is equal to negative k 66.4. Therefore, w over 66.4 is equal to k. Now, if I multiply my differential equation by the inverse of this equation, in other words, we have 66.4 over w is equal to 1 over k. So multiplying the left and the right side, here's what happens. The w will cancel out when multiplying this with this. We end up with 66.4 minus this term times this term gives me 66.4 over w kv. On the right side, I'll end up with 66.4. The w's will cancel out, and the g I'll replace with what it is, which is 9.806 dv over dt. Now I want you to focus on kv over w. Remember that we can multiply both sides here by 66.4, and we'll end up with w is equal to k times 66.4. So if we replace k 66.4 with w, the k will cancel out with the k at the bottom. Remember that this will be over here. And 66.4 will cancel out with this, leaving us with 66.4 minus v is equal to this number, which I'll find out on my calculator, 66.4 divided by 9.806, that is roughly 6.77 dv over dt. Now it's time to separate the variables and integrate. Let's start by separating the variables. The first thing that I'll do is multiply both sides by dt, and if I do that, this dt and this dt will cancel out, leaving us with the expression on the left side. And what I'm trying to do here is make one side dedicated to the t's and one side dedicated to the v's. Next, what I'll do is divide both sides by 66.4 minus v. If I do that on the left side, this will cancel out, leaving me with only dt on the left side. And on the right side, I'll have 6.77 over this expression, 66.4 minus v dv. One more thing before integrating, I want to divide both sides by 6.77. That way I have the numerator vacant with only the number 1. So if I divide this by 6.77, this goes away. And on the left side, I'll have 1 over 6.77. Now we are ready to integrate. And I'll highlight what it is that I'm integrating. I'm integrating the following with respect to t. And on the right side, I'm integrating, there should be a 1 here, 1 over 66.4 minus v with respect to v. The left side is easy. Our answer becomes simply t over 6.77 because I'll pull this out and integrating 1 is simply t. On the right side we have to do a substitution. I'll set u is equal to 66.4 minus v, differentiate both sides with respect to v, du is equal to negative dv, therefore negative du is equal to dv, and I'll replace the dv with negative du. This gives me negative du, what I set the denominator, which was u. Pulling out this negative, I end up with negative times the integral of 1 over u, and that is a commonly known integral. It is negative ln absolute of what we set u as, which was 66.4 minus v. And the constant will not go over here, it will go over here. The reason why is because t is the independent variable. So remember that. Always put the constant with the independent variable side. I'll take this expression and place it right there. Next, I want to eliminate the ln. But before I do that, you want to make sure that there's no coefficient in front of it. So I'll divide both sides by negative 1. Dividing this side by negative 1 makes this positive and makes this expression negative. Don't worry about the constant. Whether it's negative or positive, it won't affect the outcome here. Now I'll raise both sides to the base e, raising this side and this side to the base e. The e will cancel out with the ln. We end up with 66.4 minus v on the right side. And evaluating negative 1 over 6.77 on your calculator should give you roughly negative 0.14. So I'll use that instead. Negative 0.14, and if you want to be exact, it's actually negative 0.148 times e to the power of c. Instead of e to the power of c, I'll use c subscript 1. It's easier to read. C subscript 1 times e to the power of negative 0.148. T is equal to 66.4 minus v. Since v is equal to 0 when t is equal to 0, this will become 1 because e to the power of 0 is 1. And this will become 66.4 minus 0, which is 66.4. Therefore, our final equation becomes v is equal to 66.4 bracket 1 minus e to the power of negative 0.148 t. And I modeled this using the equation we found up here. I solved for v, and that's what I end up with. Part B of this question also asks us what happens at t is equal to 0.75. So we replace this t with 0.75 and we'll know what the velocity is after 3/4 of a second. You should end up with 6.98 meters per second. And there you have it. That is how to solve exponential growth and decay with differential equations.